All right, on to partial fraction decomposition. So the idea with partial fraction decomposition is to undo a common denominator. So that's what we're working on here, undoing a common denominator. The first thing you need to do is factor your original. So I'm going to factor my denominator, x squared plus 5x minus 14. And that's going to factor to x plus 7, x minus 2. And so really, x minus 5 over x plus 7 times x minus 2 is the same as some term over x plus 7 plus some term over x minus 2. We're going to call those a. And this here, when we're working with these are just two linear terms. Always our first step is going to be to clear our denominator. So we're going to multiply both sides by x plus 7 times x minus 2. And on the left-hand side, our denominator going to cancel, so this is left with x minus 5. Over here on the right side, when I multiply an x plus 7, my x plus 7's cancel. And I'm left with a times x minus 2. When I multiply into my b term, my x minus 2's cancel, so I'm left with b times x plus 7. And our process from here is just to pick some convenient x's to zero out our coefficients of a. So the first convenient x I'm going to pick is x equals 2. Because if I make x2 my a coefficient, it's going to zero out. So I'm just going to work through that really kind of methodically. Putting in 2 for all my x's. And this one is going to zero out here, so this whole term is gone. 2 minus 5 here, I have negative 3. 7 plus 2 is 9. So if I divide through by 9, b is negative 1/3. Similarly, we're going to zero out our b. So I'm going to make x negative 7. Plug it in everywhere. And when I'm doing this, I'm going back up to this line for a reference here. Negative 7 minus 5. Kind of ignore all this in the middle. That was all us finding b. Now we're going to do the same process to find a. 7 minus 2 plus b. Ooh, negative 7. Negative 7 plus 7. So my b term here does zero out. I end up with negative 12 on the left-hand side, negative 9a on the right-hand side. Divide by negative 9 and reduce. 3 goes into 12 4 times. 3 goes into 9 3 times. So what does all this mean? What's this a and b mean? Well, those are our numerators back up here in our original problem, which was right here. So there are a couple ways you can write it. You can write 4/3 on top in place of the a, or you could write it like this: 4/3 x plus 7. Whichever way you want. I kind of like writing it like the fraction. So we had two denominators. We had x plus 7, and we had x minus 2. And our a goes over our x plus 7, and that's 4/3. Again, you could write the 4/3 all in the numerator. It's 1. And our b was negative 1/3. That goes over, either over or with our x minus 2. So that fraction is decomposed. Done and done. All right, let's look at 35, another partial fraction decomposition. For this problem, we have a square term in the denominator. And if you'll remember, the way we need to deal with the square term is that we need the singlet and we need the squared. They're both linear, so we can just have a and b up top. If you had an irreducible quadratic like x squared minus 3 or x squared plus 3, that's when you would have ax plus b up top. But since x plus 3 is a little linear guy, and x plus 3 squared is still linear, you're looking at this little, the exponent there to decide if they're linear or not. That exponent on the x. Then you just need to keep. And now these are going to work just like the last problem. The first thing we're going to do is clear our fraction. So we're going to multiply by x plus 3 squared. And when I multiply here on the left side, I'm just left with the x plus 1. When I multiply on the right side, remember there are 2 of these. So one of them is going to cancel this x plus 3 with one of them. So I'm going to be left with a times x plus 3. But when I multiply into the b term, they're both going to cancel. So I'm just going to be left with b. We can still use our convenient x. We're still going to use convenient x's here. The obvious convenient x to use is negative 3 to get our a term to 0 out. So that gets our a term to 0 out. And so b is negative 2. We could think a little more on the setup for this one, but I think it's easier than the last problem. So now it's not obvious what our next convenient x is, but we know b is negative 2, and I'm just going to use x as 0 because that's easy. I'm going to go ahead and plug in that b is negative 2 as well, and then we'll just have one variable, the a. So sometimes you have to use that value you just found if you're running out of scenarios where you could zero things out. So here our x is 0, so 0 plus 1, a times 0 plus 3, plus, and we know b is negative 2. And now, again, one variable, a, one equation, we can solve. So 1 equals 3a minus 2. Add our 2. Divide by 3. So again, the setup took a little more thought, but our problem I think was easier. So our original problem was x plus 1 over x plus 3 quantity squared. And decomposed, that is, our two denominators are x plus 3 and x plus 3 squared. And our numerator a goes over the singlet x plus 3, that's 1. And our numerator for b that goes over our squared is negative 2. And you can put that minus. You can always find a common denominator and add those fractions and make sure you get x plus 1 over x plus 3 quantity squared. You are just undoing that common denominator system. All right, that's partial fraction decomposition.